Now, provided that what we have is a capacitor that's sitting in air, then the things that this charge depend on and what the voltage depends on turns out to be how big an area we have on these parallel plates is one of the things that it depends on. Also, we have this epsilon zero that came up in the calculations that we were doing before. It's related to K. Okay? And the distance between the two plates is also important. Now, it turns out that's just for a capacitor where we have no dielectric. A dielectric is a material in between these two plates that could make it harder for charges to move from one side to the other. We don't want them to arc across. So in some cases, we could just have an air separation, in which case this additional term kappa would be equal to 1. But we could put a material in there, plastic, glass, oil, various other things, that would have different values of kappa, and that would be called the dielectric constant. So between those things, we can see this is a constant. This is a material constant that depends whether or not we're putting in something in between these two. And other than that, the capacitance depends on how much area there is in these plates and how far these plates are apart. And if they're closer together, then obviously this number being smaller makes the entire thing bigger. The capacitance is bigger. And if they're further apart, then the capacitance goes down.